Good morning. Today we are going to talk about matrix. In order to use matrix in finding equilibrium later on. What's meant by a matrix? Matrix is a collection of numbers ordered by rows and columns. Say, for example, X is a matrix of 2 rows and 3 columns. So this is 2 by 3 matrix. 2 stands for number of rows and 3 stands for number of columns. So we can write the matrix as X equals A11, which means the element A in row number 1 in column number 1, A12, the element A in row number 1, column number 2, A13, etc., till we reach A1M, A21, the element in the second row, first column, A22, and so on. And the last one, AN1, AN2, AN3, and so on till we reach ANM. So this is a matrix of n multiplied by m order, where n stands for number of rows and m stands for number of columns. What are the different forms of matrix? There are vectors, which is a special case of matrix. There are row vector and the column vector. With respect to row vector, it consists of only one row. So this is 1 by 3 matrix, or known as row vector. While with respect to column vector, it consists of only one column. So this is 3 by 1 matrix, which is a special case known as column vector. What about identity matrix? Identity matrix is the matrix whose diagonal is 1 while all other elements are 0. It's of any order. It can be 2 by 2 or 3 by 3, anything. 4 by 4. So mainly the main idea is that the diagonal is 1, all other items are zeros. And this is 4 by 4, for example. So the diagonal is 1. So this is identity matrix. Now we are going to talk about matrix addition and subtraction. Say for example matrix R is the summation of matrix A and matrix B. So this is matrix A, 8, negative 4, 3, negative 7, 1, 6, and the matrix B equals 1, 9, negative 2, 3, 6, and 0. We would like to find matrix R. So this matrix is 2 by 3 matrix, and this one is 2 by 3. So we are going to have a matrix 2 by 3 matrix. In case of submission, A and B must be of the same order. So in this case, we are going to add 8 plus 1, which is 9, negative 4 plus 9, which is 5, 3 and negative 2, which is 1, negative 7 and 3, which is negative 4, 1 and 6, which is 7, and finally 6 and 0, which is 6. So this is 2 by 3 matrix, which is calculated as the summation of A and B. We are going to calculate each element with the corresponding element in the other matrix. The same in case of subtraction. If you would like to subtract, so it's going to be, if you would like to find A minus B, it will be 8 minus 1, which is 7, negative 4 minus 9, which is negative 13, 3 minus negative 2, which is 5, negative 7 minus 3, which is negative 10, 1 minus 6, which is negative 5, and finally 6 minus 0, which is 6. So this is A minus B, or say for example U. So subtraction and addition are similar to each other. What about multiplication? In case of multiplication, we are going to talk about number 1 scalar multiplication, number 2 row or vector multiplication, and finally matrix by matrix. Number 1, scalar multiplication, which means that we are going to multiply the matrix by a number. Say for example Rij, where I stands for the number of rows and J stands for the number of columns, equals Abj. So if you are going to multiply vector B by scalar which is 8, say for example A equals 8, and we would like to find R will be calculated as A multiplied by Bj. So in this case, it will be 8 multiplied by 2, 6. So we are going to multiply 8 by 2 and 8 by 6. So we are going to have a vector with the same order, 16 and 48. What about multiplication of row and column together? Row vector and column vector. Say for example row which is A, 1, 7 and 5. It's of order 1 multiplied by 3. And the vector 4, 1, 2, 4, which is 4 multiplied by 1. Actually, you cannot multiply these vectors together. It's not legal. As in order to be able to multiply two vectors together, this number should be equivalent to this number. which means that if the row vector is 1 multiplied by 3, so the column vector should be 3 multiplied by 1. If it's 1 multiplied by 2, the column vector should be 2 multiplied by 1, etc. So another example, A equals 2, 6, and 3, which is 1 multiplied by 3, and the column vector is 8, 1, and 4, which is 3 multiplied by 1 as well. So now we can multiply both of them together. And in this case, we are going to get 1 by 1 matrix, which is a scalar, as it will be 2 multiplied by 8 plus 6 multiplied by 1 plus 3 multiplied by 4. So the summation will be 34. So the multiplication of A and B together will be 34. So once again, if A is 1 multiplied by M and B is N multiplied by 1, so the result will be 1. Sorry. What about multiplication of matrix? This is A, which is 2 by 2 matrix, and this is B, which is 2 by 2 matrix. We would like to multiply them together. So we are going to have a matrix AB, which is 2 by 2 matrix as well. So it will be 3 multiplied by -1 plus 5 multiplied by 4. So it is row multiplied by column. So this is the first item. With respect to the second one, it will be 3 multiplied by 0 plus 5 multiplied by 7. So the first row is multiplied by the second column. Now we are going to move to the second row. It will be 4 multiplied by -1 plus 6 multiplied by 4. And with respect to the second item, it will be 4 multiplied by 0 plus 6 multiplied by 7. So it will be 17 and 35, 20 and 42. So due to multiplication of A and B, we are going to have a matrix which is 2 by 2 matrix. Another example. If A equals 1, 3, 2 and 8, 4 and 0, so it is 3 by 2 matrix. And B is 5 and 9, which is 2 by 1 matrix. As we said, the condition in order to be able to multiply both of them together, that this number should be equivalent to this number. Or in another words, number of columns is equivalent to number of rows in the second one. As a result, we are going to get a 3 by 1 matrix. We are going to get matrix 3 by 1. So AB will be calculated as 1 multiplied by 5 plus 3 multiplied by 9. With respect to row number 2, it will be 2 multiplied by 5 plus 8 multiplied by 9. Row number 3, 4 multiplied by 5 plus 0 multiplied by 9. The final answer is 32, 82, and 20, which is 3 by 1 matrix. What about the inverse? In case of matrix, we couldn't divide by a matrix, but we have to calculate the inverse. Inverse of A is 1 over A, or we can write it as A to the power negative 1. So we have to find the value of A to the power negative 1. If you are going to multiply A with its inverse, so you are going to get the identity matrix. So if we multiply the matrix by its inverse, this is equals to I, which is the identity matrix, or 1. If you would like to multiply half multiplied by 2, so the answer is 1. This is the same just like this one. 2 and a half, 1. Okay. So let's take an example. This is the matrix X, for example. It's 4 and 7, 2 and 6. We can write it as A, B, C, and D. So the first step in order to find the inverse is to find the determinant. Determinant is calculated as, in case of 2 by 2 matrix, this is the first case. 2 by 2 matrix is completely different than any other higher order. AD minus BC, AD minus B multiplied by C. So in our step, it will be 4 multiplied by 6 minus 7 multiplied by 2. So the answer is 10. So the determinant of this matrix is 10. Second step, swap position. Our matrix was 4, 2, 7, 6. So now we can write it as 6, 7, 2, and 4. Step number 3 is to apply sign rule or change sign. This is the original matrix. Then we are going to apply the sign rule, which is positive, negative, positive, negative. So this is positive as it is, while this is going to be negative. and this is positive as it is, while this is 7 is going to be negative. So the new matrix will be 6, -2, -7, and 4. Step number 4. Adjoint matrix. In this case, we are going to convert rows to columns and vice versa. The matrix was 6, -7, -2, and 4. So now the adjoint matrix will be 6 and -2, -7, and 4. So this row will be converted to column and this row will be converted to the second column. Finally, the last step, which is to calculate a to the power -1, which is 1 over the determinant multiplied by the adjoint matrix. So it will be 1 over the determinant was 10 multiplied by the adjoint 6, -7, -2, 4. So it will be 0.6, -0.7, -0.2, positive 0.4. So this is the inverse of the matrix. If you would like to check or make sure that we have calculated correctly, we can multiply the original matrix, which was 4, 2, 7, and 6, multiplied by the adjoint, the inverse, which was 0.6, -0.7, -0.2, and 0.4. Then the final answer would be 4 multiplied by 0.6 and 2 multiplied by 0.7, just like the multiplication of any two matrices with each other. So the answer would be 1, 0, 1, 0. So this is the identity matrix. As we said, A multiplied by a to the power -1 equals I. So this is A, and this is a to the power -1, and this is I. Another example. This is the matrix required to find the inverse. As we said, step number 1 is to calculate the determinant. It will be 2 multiplied by 3 minus -2 multiplied by 4. It's 14. Step number 2 is to find cofactor matrix. It's 3, 4, 2, -2 and 2. And now we are going to apply sign. It will be positive, negative, negative, which is positive, positive, negative, number 4 adjoint matrix. It will be 3, 2, -4, and 2. And finally, the last step is to find the inverse, which is calculated as 1 over the determinant multiplied by the adjoint. So it will be 1 over 14 multiplied by 3, negative 4, 2 and 2. So it will be 3 over 14, negative 2 over 7, 1 over 7, and finally 1 over 7. It is 2 by 2 matrix. This is the end of our lecture today. Thank you.